Today we're going to learn calculus. And one of the reasons why I want to teach calculus today is because a lot of people have issues with calculus. They say it's too difficult and challenging, but it is not. I think the biggest reason is people learn calculus the wrong way, and there is a right way to learn calculus. There's a very good way you can learn calculus and you enjoy it. The right way to learn calculus. And my job today is to teach you that right way. When I was in school, I had issues with calculus myself, and I tried my best to learn it. And during that period, many years ago, one thing that I realized about learning any subject, whether it's calculus, which is mathematics, English, or any other subject like chemistry or physics, is that to be able to learn those subject very well, or any topic to begin with, is that you need to understand words, terms that are used in those subjects. So in calculus, it's the same thing. People try to learn calculus by trying to cram, or they have basic or incomplete understanding of the terms that are used in calculus. So what I really want to do is to go line by line and teach you calculus the right way, the correct way, which means you understand it to the best of your ability. You understand it, and I'll try my best to teach you calculus in such a way that you begin to even teach other people. So one thing I want to do first is definition of terms. So we're going to define different words in calculus. You probably have heard about it, but I'm going to try my best to teach you those terms, right? One thing you see is you hear the word differential, right? And you also hear the words integral, right? You'll be asking yourself, what do these terms mean? You also hear the word function, okay? You hear the word function. You will also hear things like dependent, and independent variable, right? You hear things like that. You hear words like, and this one is very simple, differential coefficient. Right? You hear all these terms: differential, integral, function, dependent and independent variable, and you also hear differential coefficient. So what I'm going to do is I'm going to go step by step, and I'm going to define these different terms for you. I'll also give you examples of what it means so that you will know exactly what we're talking about. I'm not going to rush it. I'm going to try my best to explain to you what these terms mean. They mean something. And once you understand what they mean, it becomes easy to understand calculus, right? So let's take the first one. We'll call it differential. I'm going to take differential, the first one. Differential. Let's do that one first. When you hear the word differential, don't get scared. What it really means is this: a little bit off. That's what it means. So when someone says differential, they mean a little bit off. So a little bit of anything. It could be a little bit of sugar, a little bit of salt, a little bit of time, a little bit of anything. So when you hear the word differential, simply what it means is a little bit off. Okay? And we use the way we write that in math, we use something called d, a small d. So when you see this d, this means a little bit off. That's what it means. Isn't that simple? Differential. So when you hear the word differential, it just means a little bit of something, okay? And that is why we just don't write d by itself, right? We write dx, which means a little bit of x. That's what it means, dx, a little bit of x. So we don't put it off and they'll just put dx, which means a little bit of x. So you can say differential of x, okay? It's the same thing, differential of x. A little bit of x, okay? So that's what it means. So when you see something in calculus, so the differential of these, what they're saying is that the differential or a little bit of a particular substance or a particular variable or a particular anything really. A little bit of water, a little bit of salt, a little bit of sugar, a little bit of time, a little bit of distance, a little bit of volume, anything you can think of. Differential, that's what it means. You might be wondering, why is my board on the floor like this? This board is very heavy, extremely heavy, and it was on my wall for a long time where I have it on my wall where I like to teach. But then it fell off because of the weight of the board. So what I did was I moved it from the location where it's at, put it here, and so that I can use it temporarily until when I find a solution. I don't want to hang it on my wall anymore because it's just going to damage the wall. So I'm probably going to design something I can put like a wood that will have like a kind of like a platform that I can set this on. This is very heavy, so that should be a very sturdy wood also that is maybe this tall, so that this one can come up, so I don't have to bend down. Okay, but for right now, that is what I have to work with. So again, I'm just trying to explain to you what a little bit of or differential means. So when you see the word differential, don't be scared. That's what word we use in calculus, and it just means a little bit of something. So for example, let's say we have 5 grams, okay, of sugar, okay, and that 5 grams we call it x, okay. So a little bit of 5 grams we call, say, a little bit of dx is equal to is the same thing as a little bit of 5 grams of sugar, okay. So that's just what it means. It's very simple. A little bit of something, okay? I'm going to give you some small examples to illustrate what we mean by a little bit of something. So we use, again, differential. Instead of writing the whole word differential, we use D. And D means a little bit of something. Differential means a little bit of something, okay? It could be anything, just a little bit of it. Say you have... Let's do one example. So you have, we're going to clean this up, okay? We're going to clean that up. So let's say you have one orange, okay? One orange. Okay? I can I can split this orange into half. So I have 1/2 and 1/2. Okay, so I split it in half. Okay, this orange is now x, so call it x. So a little bit of this orange, we can call it half, right? So if I want to write this in differential, I'm going to say dx. Okay, a little bit of x is, I'm going to take this one side of it, a little bit of x. Okay, that's it. So, or if I split this orange into more parts, so I have, let's do another one. So I have 1/4, because I want to give it to 4 different people. Okay, so I have 4 people in the house, and we only have 1 orange. Okay, we only have 1 orange. Okay, so that 1 orange I split into little pieces. Okay, a little bit of it. So when I split it, I did it 4 places. So each person in the house can have a quarter each, right? So I can write this as a little bit of let me use the first one, differential. Okay, differential of x. Just one differential of x. Okay, so just one of it. So that will be 1/4. Okay, that's one of it. Another way we write in mathematics is dx, a little bit of x, or a little bit of that orange is also 1/4. Now in some textbooks they use big capital D, right? So a little bit of x, you can use capital D. Most time we use small d. A little bit of x is 1/4. So you can see how this word differential means, a little bit of something. Okay, so a little bit of that 1 orange, for example, in this case is a quarter. A little bit of that orange is a quarter. Let's do another example. Okay, so I'm going to leave this one down here. I'm going to come to this side. Let me draw a line. Let our x this time be time. Okay, let's call it time. And this time, let's call it, say, 1 minute, right? 1 minute. Okay, let's call it 1 minute. So a little bit of time. We want to write it in differential way. Okay, a little bit of time. So I can say, in 1 minute you have little bits of time in 1 minute. For example, in 1 minute you can have 60 pieces of 1 second, right? That's a little bit of time. You can have 1 second 60 times in this 1 minute. So a little bit of that time can be 1 second, right? It can be 1 second. Just like we did here, a little bit of 1 orange can be a quarter. The same thing in a minute, a little bit of time in that 1 minute can be 1 second, okay? So I can say, for example, dx, if I'm referring to 1 second, in this case, a little bit of 1 minute is 1/60, right? 1/60 minutes, right? So that's a little bit of time, 1/60 minutes. The same thing as 1 second, okay? So that's a little bit of time. You can also say, let's pick something else. Let's say, water entity can we use? So we'll say 5 gallons. So we'll say 5 gallons of water, okay? 5 gallons of water could be the whole that we have. A little bit of that 5 gallons could be just 1 gallon. So 1/5 in this case, gallons of water. So it could mean many things. It's just you understanding what that word differential means. Again, let's recap. Differential means a little bit of something. When you see the word dx, that x is now, that's something has been identified, and that's what we call it x. And that x could be anything. It could be time, it could be volume, it could be water, it could be sugar, it could be anything you want to call it. Just think about it. A little bit of anything, okay, is that x. Okay, so that is really what it means. Okay. Trying to see what other examples I can give. What other example I can give? let's choose 100 gallons. Let's say 100 gallons. So let's example 2, right? Example 2. Let x be 100 gallons of fuel, right? And I want to write it in a differential of, I'm giving somebody a little bit of that 100 gallons of fuel. Say I'm giving them 5 gallons. I just want to give them 5 gallons instead of the 100 gallons. So I'm giving them a little bit. So a little bit of that would be 5 over 100, right? I'm giving them 5 gallons of fuel. That's what I want to give them. So I can represent it to say dx is differential of x. A little bit of x that I gave out is 5 over 100, okay? That's what I gave. I gave that person 5 over 100 of what I have. Let's call it, that would be 0.05, okay? So that's what I give the person. I give the person a little bit of my 100 gallons, and that a little bit of that 100 gallons is actually 0.05 gallons that I gave them, you know? So that is how we define differential. Differential is a little bit of something, okay? We use D to mean differential. So when you see D, it means a little bit of something. Dx means a little bit of x. Now, x will be defined to you. In some cases, maybe not, but in most cases, they can tell you that x is something. It could be even the speed. You know, maybe the speed was increasing a little bit. Maybe you have some speed, and then you reduce or you took a little speed out of of the entire speed that you had. You know, something like that. It can be x, can be anything. So that is what that x means there. A little bit of something. An example of what I just showed you is that. So you have, this is a first order differential. So if you take a little bit of something, that becomes a second order. So that's what we're going to talk about, second order, right? So let's go to second order. We're still talking about the meaning of differential, okay? So first order, and let's do second order. So second order, right? Second order, okay? So second order is a little bit of a little bit. All right? A little bit of a little bit. So say I have, now let's use money in this case. So I have $100, right? That's what I have. I have $100. And I promise somebody that I'm going to give them 1% of my $100. In this case, 1% is $1. So I promise the person I'm going to give them $1, okay? And then the person, let's say person 1, okay, person 1. So person 1 now tell person 2 that if I get what I want to get from the main man, let's call this man the main person. If I get what I want to get from the main man, I'm also going to give you 1% of what I get from him. So person 2 is going to get 1% of what he got from this person. So in this case, 1% of $1 is 1 cent, right? So second, so that is a little bit of a little bit, okay? So you see it's becoming smaller. So a little bit of A, and then from that A, you now get a little bit, B now gets a little bit of A. So it becomes really, really small, right? So a little bit of a little bit is really, really small. As you can see in this case, a little bit of $1 for the first person is $1. 1% in this case. And then the same person now promised a second person a little bit of whatever he gets from the first person. 1% of whatever I get from the first person, in this case, is 1 cent, right? So a little bit of a little bit is smaller. 1 cent is very, very small compared to the overall. 1 cent compared to the overall is really, really small, right? So as you go to the second order of something, it becomes smaller, right? That's what it means. So another example, I'm going to show you how to write this in calculus. But I just really want to explain to you first what a little bit of something is, and the second order of that, what that means in calculus. So a little bit of one and a little bit of something else, right? So I'm going to clean this off. I'm going to come here. That way we have enough space to write. If I am going too fast, or I am speaking too fast, let me know in the comment so that I can slow down. I'm trying my best to slow down. I am naturally a fast talker, so I tend to talk fast. So the first one we talked about earlier is the first order differential, right? And this last example is the second order differential, a little bit of a little bit. So example 2 of that, I'm going to call it second order. That way we know what we're talking about. Second order differential, right? So it's usually written as d squared, okay? A little bit of a whole, right? That's what it means, which means a little bit of a little bit, okay? A little bit of a little bit. I'll give you another example. So in 1 hour, okay, you have 60 minutes, right? And then in 60 minutes, you have how many minutes make up how many seconds make up a 60 minutes? In this case, that would be, in 1 hour, in 60 minutes, you have 360 100 seconds, right? That is 60, because 1 minute is equal to 60 seconds, right? So in 60 seconds, right? So if you have 60 minutes, just times it, that will give you 3600 seconds, okay? So that's what that means. So we can convert the 60 minutes also to seconds. That way you can see exactly what I'm talking about. So let's convert this 60 minutes to seconds. So sorry, I'm trying to say, yeah, I'm right, I'm correct. Okay. So we're done here. So that is that. So basically, what I'm trying to say is 1 hour is equal to 3600 seconds, right? 1 second is very small compared to this, compared to 3600 seconds. 1 hour is very small compared to that 3600. 1 second is very small compared to 3600. Okay, so that's the second order right there. It's the first one, and then you have it. So if you choose a small bit of a small bit, then you're already at second order. Another example I can give is, say I have pizza. I have pizza, and I cut the pizza into 4 parts, right? 1, 2, 3, 4. So I cut the pizza into 4 parts, and I share with person A. I share just one of it. I keep 3 to myself. So me, I take 3 over 4, and then person A takes 1 over 4. Okay. Person A now gave person B. Person A now gave person B out of this 1 over 4, which is something that looks like this. I can't draw pizza very well, but person A now gives this 1 over 4, this 1/4, half of what he has. Okay, so he gave half of this. So half of this is going to be 1 of. So the over half of this is, of course, times 1 over 2. So that's 1 over 8. We want to go to the answer straight. So that's 1 over 8 of the entire thing. So person B, it should be person B. Person B had 1 over 8 of the entire thing, because now if I have to sum it up, if I have to sum everything up, if I want to combine it to one whole again, that means that me, I got 3 over 4, right? Person A got 1 over 8 because he gave half out, and then person B also got 1/8. All this combined should give you a whole piece. You know, it should give you 1. So if you add it together, this is 8 right here. So here you have 2, 6 plus 1 plus 1, right? So that is 6 plus 1 is 7, 7 plus 1 is 8, 8/8, and that gives you 1. So that is a whole. So if you add everything back, it should give you back 1 pizza. But in the large scheme of things, person B only got 1/8 of the whole, which is very, very small because he got 3/4. That right there is a little bit of a little bit. Person B got a little bit of a little bit that person A got, and that's the explanation for second order differential. When we start working on differential themselves, you will really understand what I'm talking about. I hope I've been able to explain to everybody what differential means. So let's go to summary. I'm going to go to summary first before I go to the next term. Let's go to summary. Let's do the summary so that it ties everything together. So the first thing you want to understand in calculus is what differential means. So let's talk about what that means. Again, let's just do differential. When you hear the word differential, it means a little bit of, okay? A little bit of something. Differential in calculus, we use the small letter d to write it. So d is the same thing as differential. And it means a little bit of. Okay? When you see differential and x, it means differential of x. That's what it means. Differential of x. And it also means a little bit of x. And then we say x can be anything. X can be anything, okay? That's what we said. For example, x can be time, volume, sugar, any substance, salt, anything, okay? But you have to be able to quantify it, but can be quantified. Can be named or quantified. You need to name it or quantify it, okay? Okay, so that is x. So x can be anything. And then we now use this in an example, in summary. So we say, assuming that x is, assuming that x is $100, right? In this $100, you have how many dollars? You have $101. So you have in $100, you have $1 100 times. Okay. So if you have $100, I can give you $1 100 times. If you add up all that $1 I give you 100 in 100 times, it's going to amount to $100, right? So a little bit of that $100 can be $1. So let's use that as our example in this case. So a little bit of x in this case is $100, can be 1/100, right? Dollars. Okay, can be 1/100. In this case, that just means $1. Okay, $1. So a little bit of x can be 1 or equal. The same thing you can say equal to $1. That's an example. Okay, and all this right here is the first order differential. Okay, so a little bit of x in this case is $1. I can also use instead of using $100, I can also say, for example, I give you, let's use the word $20, and inside $20 you have $1 20 times in $20. So a little bit of, if I want to write it in differential, a little bit of x, let's say the x in this case $20 will be 1 over 20, and if I give you 20 times, you get $20 back, right? So let's do that. So that is the summary, and then we have a second order differential, because second order, let me go up, let me take this one out. I'm going to take this out. I don't want to bend down too much. So second order, I'm going to write second order. So let's continue from here, dx, because we from here dx squared. So the second order is a little bit of a little bit. So we say a little bit of 100, because x is 100, is $1. And then a little bit of that $1, because in $1 you have 100 cents, right? So 100 cents is going to be 1 over 100. A little bit of that overall, we're still using x in this case, is 100 times 100, right? Because a little bit of $1 is 100 cents. So if you had everything together, that should give you 1 over, if you times it together, sorry. So that's what you get. So that is that. So that is the second order equation that you have. If this confuses you, this one is the first one, a little bit of that 100, 1 over which is $1, and out of that $1 is equal to 100 cents, right? $1 is equal to 100 cents. So 1 cent is, if you in dollar form, call this one, let's call this one y so I don't confuse it. Just so I can explain this to you. So if you call this one y, just do your cross multiplication, okay? That $1 is equal to 100 cents, and then you're looking for what a dollar is in a cent. That's what we're looking for. So that's what a y is. So y times 100 is equal to $1 times 1 cent, okay? So divide that, y is equal to $1 times 1 cent divided by 100, right? You get that? So that, if you divide that, that should give you what you're looking for. So this should be in cents, okay? So that cancels out, so you don't make a mistake. So 1 times 1 is 1, and then you have y is equal to $100. Basically, that equals to $0.01. That's what it means. Okay, so that's what that means. So that's how I got this right here. So what you see right here is what I put right here as 100 times 100, and that's how I got this right here. So the second order of the little bit of x, which is a little bit of a little bit. In this case, that little bit we say is 1 cent. It's going to give us 1 over $10,000. Okay. So that is the second order differential. Okay. So now I'm guessing that you understand what differential is, and if somebody asks you what a differential is, you are able to explain to them what a differential means in calculus. So the next one we're going to talk about is integral. Okay.